Alright, the next one is an example of the Chinese remainder theorem, or CRT. So there was two assessments. I said there was two different questions, so I'll do the two questions in turn. So this was off one of the papers. It was find x such that x is congruent to 4 mod 8 and also congruent to 5 mod 27. Okay, so we're used to doing these with 3. It should be even quicker with 2. So start off, we find the big modulus, which is the products of all the moduli. Remember, these have to be relatively prime to each other. All the moduli are called pairwise relatively prime. For instance, if that was a 26, there would be no solution because 8 and 26 have factors in common, i.e. 2. Or if it was 28, they would have factors in common 2, 4, etc. There's 8, the only factors of 8 are 2 cubed, and 27 is 3 cubed. So no factors in common, so they're pairwise, they're relatively prime to each other, so a solution exists. So the big M, or the modulo overall, is 8 times 27, which is 8 20s is 216. So we know that a solution exists modulo 216. So less than 216, there is a guaranteed solution. So we do our M1. Remember, M1 is M divided by the first modulo, so 8. So that's 27. And M2 is 27, or it's going to be 27 anyway. It's going to be 216 divided by the other moduli, which is only 27, so that's 8. Okay, so obviously it's just the, when there's 3 in there, we want to get the first one, we just multiply the other 2, and then they get the second one, we multiply the other 2, etc, etc. So when there's only 2, it's always going to be the opposite one, so the 1 mod 8 will work in 27 and that one there. So we've got M1 and M2. The remainders we just read straight off. The remainder of the first one is 4, or residual sometimes called. R2 is 5. Okay, then we need the solution to the modulo equations. Remember, I take this 27 here, so I go 27 S1, so this is our first solution, is congruent to, instead of 4 mod 8, it's 1 mod 8. Right, remember, you've got to put that in, it's congruent to 1 mod 8. And the second one, I'll put down here, hopefully there's enough room to do it, it will be this times here, so it's that 8 times S2 is congruent to, and instead of 5 mod, it's 1 mod 27. Okay, so we need the solution. The last two pieces missing in the puzzle are the S1 and S2. Now, the fact that I'm working mod 8 means I can reduce this mod 8, which means it becomes a hell of a lot easier. Otherwise, I can find what's the inverse of 27 mod 8. That's the question I'm ultimately trying to do. Because I'm working mod 8, divide that by 8, which is 24, and 3 over. So 3 S1 is congruent to 1 mod 8. So I need the inverse of 3 mod 8. Remember, it's not going to be 7. It's unlikely to be 7 anyway. And it's never going to be 1, so it's 2, 3, 4, 5, 6, generally speaking. So if I go like 3 2s are 6, which doesn't have a remainder of 1 when divided by 8. 3 3s are 9, which has a remainder of 1 when divided by 8. So S1 must be 3. Okay, so it's its own inverse. So 3 3s are 9, which has I divided by 8 and I get 1 remainder. The next one, I'm working mod 27, so I can't reduce it down. So I need the inverse of 8 mod 27. Okay, so I might have to do an extended Euclidean algorithm to get this. So it's good to have both different types. You can see how you can do it in your head, and you can do the extended if necessary. So 27 is going to be equal to 3 8s plus 4. 8 is going to be equal to, is that right? 3 8 to 24 plus 3. Don't want to make any mistakes on video because I'll have to start again. So 8 is equal to 2 3s plus 2, and 3 is equal to 1, 2 plus 1. Okay, then I'm going to take that back up and go the other way. So 1 is equal to 3 minus a 2. So I put 1 3 minus 1 2 just to keep as the form we've been doing all year. So I'm going to replace the 2 then. So that's equal to 1 3 minus 1 times 8 minus 2 3s, which is basically 3 3s minus 1 8. And then I'm going to replace the 3 with 27 minus 3 8ths minus the 1 8. Okay, so that's minus 9 minus 10. So 3 27s minus 10 8ths. Is that right? Minus 10 8ths. Okay, and that does equal to 1. 3 27s is 81 and 10 8 is 80. So that is the inverse. So the inverse of 8 is 8 inverse equals minus 10. And remember, I want that to be a positive number. So I'm working mod 27 So the answer is 17. Add on one multiple of 27 to get it between 0 and 27. So now I've got my solution. The solution is going to equal the sum of the mi or I si's. I equals 1 up to 2. There's only 2 of them. So basically I put down the two numbers here, the 27 and the 8. 27 with the 8 there. Put down the two r's, 4 and 5, so by 4 there, by 5 there. And put down the two solutions here, which were 3 and 17, so by 3 there and by 17 there. And a plus in the middle. Whatever this number here is going to be the answer. I have to break out the calculator again and do this. So hopefully I don't make any mistakes. 27 times 4 times 3 equals 324. And 40 times 17 is 680. So the answer is 1004. And remember, I'm working modulo 216. So I'm going to just reduce that mod 216. So minus 216 by 3 gives me 356. Minus 216 again is 140. So that's the lowest solution there is. So what we're saying is that 140 is congruent to 4 mod 8. So I'm going to divide 8 into 136. I'll just take the 4 off straight away and just go to see does 8 divide by 136. 17, it goes in evenly. And then it's congruent to 5 mod 27. So I'm going to take the 5 away from the 140, get 135 and just divide by 27 as well just to make sure. And it works. So that's our solution, 140. Okay.